The securing mobile crypto coin wallets. I think it's a fancy title, but I had to come up with one so I could get into this conference. You'll see it's actually, I hope, a pretty down-to-earth presentation. A little bit about myself because, obviously. I started in 2007 working as a software developer, mostly C++, some .NET. I spent 4 years at that company, and after that I needed a change of pace. So I went to a mobile game development company where I got promoted to the position of iOS lead. So I spent some time trying to figure out ways to block attackers, in our case, cheaters. So people who are trying to get away with hacking our games. Hacking is probably the wrong word here, cracking, let's say. If you know mobile games, you know there are a lot of in-app purchases, so people try to get away with getting free currency and advancing without having to pay. After 4 years there, I started a year and a half ago approximately at my current company, CGCom, where I was hired to work as a blockchain developer. This came because of my interest in Bitcoin mostly, but you'll see that it's not only about Bitcoin. There are a lot more crypto coin currencies out there. I made this drawing myself. I hope you like it. The point was that how it feels to be in this blockchain business nowadays. It's like trying sometimes to jam a square peg through a round hole. And I'll explain more in the next slide. The problem right now is that a lot of financial companies are experimenting with blockchain because, I don't know, I guess they think blockchain is cool, but they also understand some of the benefits. However, they are not ready to let go of their already established procedures. So there are two main concerns when you're trying to implement a business blockchain solution. One is that blockchains were really developed to be a distributed public ledger, which means all transactions are public, everybody can see them, and it's about a sort of trust through technology, whereas companies, financial institutions want to keep their data private. Obviously, you wouldn't want your bank to publish all your transactions online, especially on a distributed server system. The other issue, of course, is the fact that blockchains are, by definition, highly distributed systems, sort of a democratic computing system, whereas financial institutions rely on centralized servers for obvious reasons. So the issue is, how do we make these two play together? I will not try to mislead you. I don't have an answer. I'm just presenting the situation as it is right now. If you search the internet for blockchain, you'll see that a lot of companies are trying to experiment with it. You've got IBM, Microsoft is developing blockchain as a service systems in Azure. IBM has the Hyperledger initiative. NASDAQ launched a private equities trading platform. I think it's private equities, I'm not sure, called LinkU, I think, which runs on a blockchain. But enough about business and all that. Let's talk about the technical fun stuff, at least for me. Sorry if that was kind of silly. You probably all know Bitcoin, so the original cryptocurrency and what really started the blockchain. I wouldn't call it revolution, but it's an evolution anyway. The other, it's a bit dark, but in the left corner there's Ethereum, which is the current contender to Bitcoin. Now Ethereum evolved based evolved the concept of a distributed ledger by adding a state machine on top of the distributed ledger, allowing you to write so-called smart contracts. So instead of just having a transaction, a transfer of value, you can write a stateful object, which is like an object in Java or C++. It has its special programming language. And you can try to code actual legal contracts. The simplest example would be like an insurance. If certain conditions are met, then transfer funds to a certain address. Of course, the embedded cryptocurrency for Ethereum is something called Ether. So you could make payments in Ether. You can't make payments in euro, dollars, or whatever. Then there's Ripple, one of the earlier forks of Bitcoin that I've worked with. Ripple takes away the proof of work, which is the hash cash algorithm. You know what miners are doing. Miners on Bitcoin, they're always trying to find a hash which has a certain, which meets a certain criteria, and the first one who finds that hash is awarded the current block bounty. Of course, usually there's not one miner, there's a pool of miners who is doing that. Ripple took away that process and works on something called a consensus-based algorithm, and you can Google things like Byzantine fault tolerance, which is what they're actually doing, which means that if at least 80% of the network agrees that a certain transaction is valid, then everybody will accept that transaction as valid. What they're basing their theory on is that they expect that not more than 50%, the entire network will not collude to introduce corrupted transactions. And you can see that Ripple has already been quite successful in building its business case. It's working with banks. They are targeting international money transfers, something that is not very well regulated now. And the bank system itself does not make this easy. Then there's Monero, maybe you've heard of it. Monero is a crypto coin like Bitcoin, but it focuses on privacy. Whereas with Bitcoin, if you're not careful, your IP address or your personal details can be revealed during transactions. Monero focuses on privacy, having a crypto coin that is harder or probably very hard to trace back to the one who spends it. And then if you follow Cryptocoin news, Zcash has been making a splash lately. It's also a privacy-oriented crypto coin. It uses something called homomorphic cryptography to hide both the value of the transaction and the sender and the receiver of the transaction. I guess some people find that useful. So what about you? Do you use Bitcoin? Do you like it? Cool. So if you use Bitcoin, how do you store your Bitcoins? Do you do it offline? Do you have some sort of air-gapped machine where you sign your transactions and then publish them on the internet with a client that is connected to the internet? Do you do it on your mobile phone? Do you do it on your computer? Do you use some sort of hot-cold wallet strategy? That means you have certain hot wallets, which are wallets which are connected in, which are used to make the transfers, but your actual Bitcoins are stored, in a wallet that is on a machine not connected to the internet, and you make the transaction from the cold wallet to the hot wallets there. Nobody can steal your private key. And then from the hot wallets, you spend the funds. And the big question, do you think using Bitcoin is easy? And if not, would you like to buy some Bitcoin? I would certainly like that. By the way, I heard that Bitcoin is going up now that Donald Trump was elected. So at least some good news. So at least in my opinion, Bitcoin is not easy to use because cryptography itself is hard to understand and use. So we would have to find some way to strike a balance between usability, and security. This is what it's all about. And in the case of Bitcoin, the one secret we need to keep hidden is the user's private key. And of course, we want to put control in the hands of the user. We don't want to have, like in the case of the bank, where the bank controls your transactions. You're authorizing them through some form of authentication, but the bank itself executes the transaction. The whole point of Bitcoin was to give that power to you. So I looked at a couple of existing Bitcoin wallet applications. I found Bither, which uses a cold and hot wallet approach. As many other Bitcoin applications do, they ask you to remember a mnemonic password or store securely somehow, I guess, in a vault at home, which is, if you've seen this, it's actually a series of words, and those words can be translated into a private key. But you can't easily remember it because it's a very long phrase that doesn't make any sense. There's also Bread Wallet. I think it's more recent. Also based on this mnemonic passphrase thing, which is known also as BIP 39, which is a Bitcoin improvement proposal for the protocol. Again, it stores the private key in the device's keychain, and assuming you can compromise the device by jailbreaking it, the keychain is easily dumpable. I also found an application called Green Address, which combines storing the private key in the keychain and also a mnemonic-based passphrase with some sort of two-factor authentication, sending you an email, an SMS, something to confirm that you are the holder of the address. And I think they also use multi-signature so that you can't spend the money by yourself. You need a second signature done by their servers, which is enabled once you authenticate yourself. So in summary, most solutions use the mnemonic-based authentication and maybe some second factor authentication. Again, all these require you to write down some sort of complicated password or store it securely somehow, which is not saying that much after all. I mean, I could just store my private key on a flash drive and store and keep it in a safe and make sure nobody can copy it. It's sort of the same thing. So it's kind of a old-fashioned approach, I would say. Or maybe use a third-party authenticator, like they send you an SMS, you log in to their server some credentials. That's fine, but it's also, like I said, a bit old-fashioned. Or they do both for extra security. What I'm saying is that, in my opinion, this is not the best approach. It's not easy to use, and it's not always 100% secure. Of course, nothing is 100% secure, but we could try to find something better. All in all, I don't want to be a hater, so it's actually a good level of usability and security. However, I do believe there is a way to make things a bit better. Yep. But there's a catch, and I'll talk to you about that later on to the presentation. In order to improve the current state of things, you would have to take what they call a greenfield approach. I really like this word, and I wanted to use it in my presentation. So basically, it's going a bit back to the drawing board and not taking what has been built so far for granted and try to improve on the existing design, maybe fork it or build it from scratch. So actually what I will be proposing later is that we change the original protocol, and this is what I'm asking. So the second point there was you have to be willing to change the protocol. Something's got to give, so to speak. And the key point here is that we could start leveraging the security enhancement that are found in everyday mobile devices. And by that I mean biometric sensors. Yes, almost all devices, so many devices now have touch fingerprint sensors, which some would argue are easy to spoof, but let's face it, it takes a lot of doing. I don't think it's unless you are very adept at social engineering, I don't think it's very easy to steal a fingerprint, but let's say it's reasonably safe. Then mobile devices also contain hardware that accelerates cryptography, so it's no longer that much of a penalty hit if you're encrypting things. On iOS, you have the common crypto library and the security framework, which, if starting from the iPhone 5s, which is powered by the A7 chip, also feature the secure enclave, which was my next point. On Android, I will admit that I haven't investigated a lot, but I did read that ARMv8 A devices also feature hardware accelerated cryptography. And some Android devices have the so-called secure element, which can emulate the security found in a credit card. Also, I looked up a chip made by Atmel, which is quite inexpensive. It's called the Atmel ATECC508A, which does accelerated, hardware accelerated SHA-256 and elliptic curve cryptography and some other things. So you could, in theory, build your small embedded devices with hardware security. You can actually buy it as Arduino Shield if you want to experiment with it. So, on to what I'm actually proposing here. I propose of using the secure enclave on the A7 chip, the iPhone 5s and later, which has a very interesting feature. You can, in a nutshell, you can generate the key pair, the elliptic curve key pair, which is used for all crypto coins inside the secure enclave, do the signing inside the secure enclave, and never have the key leave that enclave. So you just feed it the data, it signs it, gives you back the signed data. So unless you have some sort of sophisticated hardware attack tools, it's going to be very hard for you to retrieve the hardware key. Unless, I guess, unless you are the FBI or NSA, it's going to be near impossible. And there's another point, even if the device is jailbroken, you still can't access that private key because it's stored in hardware. It's not in a file on the disk encrypted like it was before the A7 chip. Of course, you'll need to take some extra measures to be sure that that key is stored in a secure enclave and not on the encrypted database, which is the keychain on iOS. So, in theory, what we could do is have the secure enclave generate the key pair, which will be your wallet, a private key and a public key. A Bitcoin address is actually a hash of the public address of an elliptic curves key pair. And like I said before, you can just sign your transaction in the secure enclave, in theory totally secure, and then submit the transaction to the network. Now, the secure enclave itself is protected by whatever means of security you use on your phone. So if you're using a simple 4-digit PIN, it would be slightly easier to crack. Of course, then you have that delay. When you have too many brute force attacks, it will stop you and give you a minute delay or something like that. If you're using a complex password, that's great. And you can use Touch ID to unlock your iPhone instead of the complex password unless you restart it. When you restart it, you have to input the complex password. And like I said before, with this approach, the private key is never in RAM. So even if the device is jailbroken and you're fishing in the memory for the key, you'll never find it. So I said that in general, the secure enclave should be safe against software-based attacks. Right. Also, you have to be careful how you write your code. You have to understand the security framework, which is an iOS framework for manipulating the keychain. And also, you'll have to unlock the item in the keychain. Things that you store in this secure database are called items. It's like a database where rows are called items and columns are called attributes, but I'll show you a bit more about that later. And the trick we tried to do this in this software solution was to have the user unlock the item with his fingerprint, so it felt more sci-fi, I guess. You could also unlock the keychain item with your passphrase if you wanted to for extra security. I don't know if this is helpful because probably you can't see it unless you're in the front row, but I think it'd be more helpful when you download the presentation. These are the secret incantations you have to go through in order to set up a keychain item that will be stored in, actually here I'm generating the key pair. This is what you have to do to be sure that the key pair is generated inside the secure enclave and it's not just generated on the regular keychain. You have to set up some security attributes on the item, and then the actual generation happens in sekkey generate key pair, and it will return the public key and an opaque reference to the private key. You can never see the private key, like I said before. But you can use this reference later on if you want to sign. You can tell the framework, hey, sign with this private key. But you're not actually holding the private key, just a reference to it. And this is the signing part. Like I said before, I extract a reference to the private key, so not actually the private key. And then I sign with it, and I get a blob of data that is the signed data. If you're not familiar with this is Swift code. All right, and now to the big problem. Like I was saying at the beginning of my presentation, there's a mismatch between what business users want and what the Bitcoin cryptocurrency communities in general want to develop. In my case, the problem was that Bitcoin and every other cryptocurrency out there uses elliptic curve algorithm called CACP 256K1. And this is actually, if you know a bit about elliptic curve cryptography, it's a different curve. You have different parameters which generate a different curve. While the security standard, the NIST whatever standard, with NIST P256, is actually another curve, the CACP 256R1. And this is the elliptic curve algorithm that is implemented in the secure enclave. So I couldn't actually sign Bitcoin transactions with the secure enclave. There's also a rumor that the P256 elliptic curve has some NSA backdoor in the random number generator. I can't deny or confirm that. So what I did was modify the algorithm. Yeah, I already talked about this. Satoshi, for some reason, picked a different elliptic curve than what is the industry standard. So what I actually did was modify Ripple in my case, so that all addresses inside the Ripple are generated using the P256 elliptic curve instead of the standard one. Luckily, Ripple uses OpenSSL as the crypto library, so it wasn't that hard to change. And I've made available the forked Ripple server here, if you are curious how that works. It's on a separate branch called CACP 256R1. I never tried to issue a pull request, see if they will accept it, probably not. And the iOS application is available at the second link. Now I'll show you somewhat of a not very exciting demo with me signing a hard-coded transaction on my iPhone. Here we see the elliptic curve public key represented as a Ripple and a Bitcoin address. I'm sending myself the public key via email just to be sure. We have the public key as an encrypted hex number. It's actually hex blob, it's not a number. And then I will hit sign, which prompts me to authenticate so that it can access the secure enclave and generate the signed transaction data. I then email this transaction data. I didn't build a very user-friendly demo. And I think that slide is done. Okay, then I take that signed transaction data on my computer and I submit it to my modified Ripple network. It's probably very small. I don't know how to zoom in further. And probably not very exciting. So in here I have the signed transaction data, which is a binary representation of the transaction that I want to submit, on top of which which has also been encrypted with the private key. This is the transaction data that I want to submit. It contains my public key and some value transfer. And then I take that and submit it to my running Ripple server. And if you were close enough, you could see that it said transaction was applied only valid in published ledger. Ledger is what Ripple is calling blocks. I guess there was more, but let's skip through it. So that's it. I hope you walked away with something from this, and maybe you'll convince people to use Bitcoin, and maybe we'll find someday an understanding between the business communities and the Cryptocoin communities. Any questions? Yeah?
So one of your requirements was that the user has full control over all the data, and you dismissed, well, I mean, you didn't explicitly say that, but I think you dismissed those web-based Bitcoin wallets because the user does not necessarily have full control over everything. With this enclave approach, how does the user get full control over everything?
You mean I don't actually have the private keys, that's what you're saying?
Probably, yes.
Well, it's on my device, so I own it. If
Apple owns it, sorry. Apple owns it.
What, sorry?
Apple owns your device.
That's how you see it. But even if they own that device, they could never extract the information from the secure enclave. So the data I put there is mine.
Fair enough. Have you looked into TPM-based solutions?
I don't know what TPM is.
Fair enough.
You mean like hardware tokens?
Modern hardware ships the trusted platform module, which, well, its sole purpose is to hide keys from users, which I think the Apple Enclave thing does as well. But I mean, the TPM is standardized, and every modern platform has one of those.
Like Intel SGX, you mean?
No, I mean TPM.
Okay. No, the point to this experiment was to make something that works on a mobile device so that it's very user-friendly, not necessarily an enterprise environment. But thank you for that suggestion. Yeah, I thought about that one. Yeah, in theory, you could store your private key on the YubiKey. I did see a thread on one of the Ethereum forums. A guy had developed an applet for the YubiKey that you could load and it would do the signing for you. But you would have to have a developer-enabled YubiKey. I didn't fully investigate that, but yeah, in theory, you could do it. Of course, that only works on computers, not on mobile devices. How do you plug a YubiKey into a phone? Right, but not on an iPhone. Anyone else?
Okay, then thank you, Christian.
Thank you. Thank you very much.